Okay, everybody. Good morning to this awkward math class in your Colegio Mayor de los Andes. Hello to everybody. Hello to everyone. Remember, You are in my mind, in my soul, in my heart. The topic for today, please copy on your notebooks. Economic applications for linear equations. The objective for today is to strengthen the knowledge about how apply the economic with linear equations. So let's begin. We are here with 11 students now. Say hello to Vale, Luna. Hello, how are you, Luna? Maria Jose Hermida, how are you? Francisco Villalba, hello, how are you? What about your life? Fine, excellent. Juan Esteban Torres, hello, Juan. Hello, how are you? To Sammy Montes, hello, how are you? How are you? Excellent for today. Don't worry, no, we don't have any activity to fun to sign, okay? Don't worry about that. So we're going to wait only 2 minutes more for more students, and we're going to begin with our class, okay? Please, everybody, remember, copying your notebooks. Economic application for our equations, we have decided our session 90. The objective, remember to strengthen the knowledge about how apply the economic with linear equations. So everybody, copy and let's begin. Say hello to Valeria, to Sammy Montes that is there. Hello, Vale. Don't worry, we don't have activity for the last class, okay? The previous last class, okay? Let's begin our class in 2 minutes more. So please, everybody, come on. Okay, people, let's begin. There are some people are asking that in this moment that we have a grade of our class, the yesterday class. So no, we don't have grade. Okay, no, don't worry. That activity doesn't have grade, so don't worry about that. Okay, the objective it's on the screen. Yes, Lunita, it's on the screen to strengthen the knowledge about how apply the economic polar equation. The station. Tell me Valeria said me it's not 91, but no, I have the order here. We have 90, but don't worry, if you have 91, you can say me. Okay, some rules for our live class. So, please, the chat, the chat must be used exclusively to send teacher questions, answers, and keep comments in front of class. Okay, it's necessary that you have and pay attention to these rules are so very important for us. Second, the responsible of the same will allow a quiet class and will evidence personal writing behaviors. Please be quiet with the words that you're putting in our chat. Okay? Very good. Third, if any student leave evidence of inappropriate comments, they may be expelled from the room by the YouTube administrator. You noted that if you have, I don't know, you repeat a lot of things, a lot of words, okay, or you say bad words, the YouTube administrator can ban it, okay, can ban you. So it's important that you have this in count and will be subject to the observer affiliates, please. Some people are using bad words and that's it's not right. Okay? Very good. Four, the video it's always uploaded to YouTube. Okay? In order to be again consulted by the student in case of urgent standing and expressing press it there or it remember this is an academic material so it's normal. Okay? Very, very, very good. So please, we're going to begin our beautiful class for today. So everybody, please pay attention and stop in the chat. Sammy Montes, please. Checho, please use your institutional mail, please. Okay, Sergio, you need that we use the institutional mail. Thank you for Sammy Montes. Thank you for Francisco Villalba. Okay, no more. Let's begin with our beautiful class for today. Okay, first, we're going to know about the economic video. It's economic video about the slope and about the demand. So everybody, we're going to pay attention of this beautiful video that how can we apply the linear equations using economic topics. Okay, so please everybody pay attention and please remember the rules and the chat. Okay, very good.
Here we go. One step at a time, don't be living on the line.
In this video, we're going to combine the knowledge that we have gained about linear demand and supply equations in previous lessons to figure out how to determine the equilibrium price and quantity in a market using the equations for demand and supply. We're going to continue with the same example we used in our last video on linear supply equations. We're looking at the market for beef here. In a previous video, we derived the supply equation for beef, which we can see here. The quantity supplied of beef equals -40 plus 30 times the price. I've come up with a demand equation for beef that we can combine with the supply equation in order to determine equilibrium. The demand for beef can be represented by the equation 180 minus 25 times the price. Let's start by plotting our demand and supply curves on the graph. To do this, we must first determine the P-intercept of demand and the P-intercept of supply. The P-intercept of demand is found easily by setting quantity to 0 and calculating the price at which quantity demanded equals 0. The price intercept of the demand curve is 7.2, which I'm going to go ahead and plot on my table over here. The Q-intercept for demand is easily found because it is, in fact, the A variable in the demand equation. I know that my demand curve intercepts the quantity axis at 180, so I can put another point on my graph at a price of 0 and a quantity of 180. These 2 points allow me to draw my demand curve. Next, let's draw the supply curve. Now, we did this in a previous video, but we'll go ahead and do it again now. To find the supply curve, we must first find the P-intercept, which I do by setting quantity supplied to 0. The supply curve begins at a price of $1.33. To draw the supply curve, all I need is a second point along my curve. So I can plug in any price and determine what quantity would be supplied at that price. I'll find out what the quantity supplied is at a price of 5. At a price of $5, 110 kilograms of beef will be supplied. With these 2 points along my supply curve, I can go ahead and plot the supply curve. I've now drawn both my demand curve and my supply curve for beef. Now, it would be simple enough to estimate the equilibrium price by looking at the intersection of demand and
Okay, I put pause in this part because remember that we're learning about the solution when we have an intercept, okay, of two linear equations graph. Look at that. That we have one equation that is supplied with positive slope, look at that, and a demand linear equation with, look at that, negative slope. But we have an intercept. This intercept here that you can there with my mouse, okay? This intercept is the solution of this system equation. In this case, it's no y-axis and a x-axis. It's price and quantities. The price of this product it's 4, okay, approximately 4, okay, very good. And the quantities are like 85, 86 quantities. Look at that. That is the point that we are finding using the substitution method or the graph method. Okay, let's continue with the video.
and supply, but we also need to be able to calculate equilibrium price and quantity using the equations themselves. So it looks from the graph as if the equilibrium price is going to be around $4 and the equilibrium quantity of beef will be around 80 kilograms. But just to prove that these estimates are correct, we're going to go ahead and show how to calculate equilibrium price using the equations themselves. Let's review what market equilibrium is. In a market for a particular good, equilibrium is achieved when demand equals supply. At equilibrium price, at PE, quantity demanded equals quantity supplied. Knowing the definition of equilibrium, we can pretty much figure out how to calculate equilibrium price. All we have to do is set the demand and the supply equations equal to each other and calculate the price at which the two are equal. Let's do that now. We know that the demand for beef is represented by the equation 180 minus 25p, and that the supply of beef is represented by the equation minus 40 plus 30p. All we have to do now is solve for p in this equation, and we will know at which price the two are equal to each other. Let's do that now. Sure enough, it turns out that the equilibrium price of beef is exactly $4. I did this by setting the demand and supply equations equal to each other and solving for P. All we have left to do is to determine the equilibrium quantity. And all we need to do in order to figure out what the equilibrium quantity is plug the price into either the demand or the supply equation. We'll start with the demand equation. The quantity demanded at a price of 4 is QD equals 180 minus 25 times 4, which, as predicted, equals 80. So the quantity demanded at the equilibrium price is 80. Let's go ahead and check by plugging the price of $4 into our supply equation. QS equals negative 40 plus 30 times 4. QS equals 80. Sure enough, the quantity supplied and the quantity demanded at a price of $4 are equal to one another. This confirms that $4 is in fact our equilibrium price and 80 is in fact our equilibrium quantity. So in this video we have shown how to calculate.
Okay, I'm going to put again pause because Vale said me, teacher, I don't understand. But don't worry, look at that. We have two equations, look at that. One linear equation and the second linear equation. In this case, we are not speaking with the y-axis and x-axis. We are speaking about price and quantity. The graph that represents this linear equation is the demand. Look at that. The slope is negative, minus 25. So this equation represents this line, the demand of the product. Okay? And the supply represent this equation. Look at that. The supply graph represents QH is equal minus 40 plus 30p. We are only changing the variables, okay? It's no y variable, it's quantity. And it's no x variable, it's p. Remember, q of quantity and p of price. Okay, very good. Now look at that. We're using, in this moment, he's using another method that is equation method. Okay, but look at that. We find the price of 4. Look at that. 4 is the intercept with the supply and demand graph. Okay, look at that. 4 of price. But this 4 have to be a friend. This friend is a quantity, but I'm going to replace this 4 into this or this equation. Okay, I can, in this case, the teacher replace this 4 into the two equations to show how the answer is the same. Look at that. In the first case with the quantities, look at that. Replace price for 4. 25 times 4, okay? 85 minus 180. Okay, very good. Minus 40 plus 120, 80. Look at that. So the equilibrium in this case, it's 4 and 80. This is the coordinate, 80 in x and 4 in y. Okay, very good. Excellent. Why 80 said valid? Because look at that. 180 minus 225 times 4 is 100. Okay? 180 minus 180 is for the reason. Okay? Look at that. And in this case, it's the same. Minus 40 plus 30 times 4 it's 120. Minus 40 plus 120 is 80. It's the same. Okay? Very, very good. Look at that. Don't be confused. Don't worry. Remember, in this case, look at that. We have linear equation, another linear equation. Okay? We change the y-axis for price and x-axis for quantity. Okay? Very good. Excellent, Vale. Excellent. Very good. For this reason is 80. Very, very good, Valeria Gonzalez. Excellent. Excellent. Excellent process. For this reason, it's that we have to identify in which point we have the intercept. Look at that. The supply and the demand have an intercept. Is in this point. But which numbers? Oh, in 4 of these 4 and 80 of this 80. I can use it. I can use only the graph to find it, okay? But look at that we have a math process to know which is the price and the quantities in equilibrium, okay? But don't worry. Don't worry. Now, we're going to watch this exercise. Look at that. We have the system of linear equations in two variables. Okay? We have to solve a system of linear equations graphically. Okay? Yes, we was speaking yesterday about how can we graph this type of equation. Look at that. We have 2x minus y is equal 1. And minus x plus 2y is equal 7. Okay? To solve, to find the values for x and y. Look at that. The game in this case is that we have to identify which number is x and which number is y. But remember that the answer is 1 in this case. Okay? We know that each equation represents a line. So the solution is exactly the intersection. We need to read that fine from the graph below. Okay? Look at that. Look at that. Excellent. We have this exercise. 2x minus y is equal 1. Look at that. This is the graph. Look at that. You can see that? Yes, I know that you can see it. This is the graph of 2x minus y. It's equal 1. Look at that. Now, we have the second 2x minus 1 minus y is equal 1 and minus x plus 2y is equal 7. Look at that. Minus x plus 2y is equal 7. We have this point, okay? But we have to find where's the exactly point that we can see the intercept with two lines equation, okay? We can do it with using the graph. Remember, I can put it these equations in y terms. I'm going to use in this moment paint, okay, to show you how can we put it in y terms. Remember that if I'm going to use this one, okay, beautiful, okay. The first exercise, the first equation is 2x minus y, it's equal 1, okay. Now, okay, very good. Now, if I want to graph this equation, I'm going to put it in y terms. So it's y is equal and the other times. So in this case, I'm going to move 2x to this right side. Okay? So appear minus y, it's equal 1 minus 2x. But we have a problem here. Look at that, the negative structure. So you know that you can multiply all the equation by minus 1. Okay, by minus 1 and change all the signs. So appear now y is equal, yes, 2x positive minus 1. Yes? So minus 1 in this case is the intercept with the y-axis. Okay? Let's check it that if it's true or no. Okay, look at that. Look at that. Minus 1 is the intercept with the y-axis. And the slope in this case is 2. Remember that when we're speaking about slope, we are speaking about the change in y over the change in x. In this case is 2 over 1. So I have to move 2 positions in y to move 1 position in x. Remember that we are here. 1, 2, and 1 position. Yes, right, it's excellent. Look at that. We have the point. 1, 2, and 1. Oh, very good. 1, 2, and 1. 1, 2, and 1. Excellent. Look at that. You can construct, you can draw the line using only this equation if you want it. Okay? It's no difficult. Look at that. In this case, minus x plus 2y is equal 7 have the intercept with the y-axis in which point? Look at that. 1, 2, 3, 3.5. In 3.5 we can find the intercept with the y-axis. Look at that. And we have to move how many positions? Look at that. We are changing 1 and 2 positions. No, 1.5 position in y to move 1, 2, and 3 position in x. Look at that. And we can find the point here. Yes, we can note it if we count the squares. Look at that. In x, 1, 2, and 3. Just 3. And in y, 1, 2, 3, 4, and 5. 3.5. Okay, very good. In this moment I'm going to read some comments that you are putting in our chat. But let's set, okay, 2 equations. Okay, later you have to put on terms of p and the result of the variable. Later you have to make 2 equations replacing the variable for the very good, Valeria. Excellent. That's it that you have to do. Excellent. Santi said yes, it's good. Pachito, Francisco Hidalgo says thank you. Very good. Luna is thinking. Okay. Are freezing in this moment, but I am running the video too, and in this moment it's very good. It's normal. My internet WAP. Okay. Ballet, yes, is there. Okay. Should the video is thank Val. But okay, you're going to resolve the equation. Very good. Sammy wanted, don't worry, you are doing the equation very good, excellent. But now I'm going to erase this one. Okay, remember that this video going to be uploaded immediately in YouTube, and in this form you can check it again if you have some doubts. Okay, don't worry about it. Okay, I'm going to maximize this one. Okay, we see 3 cases when solving linear. Remember, 1 intersection, 1 solution. But if we find parallel lines, no intersections and no solutions. Okay? But if the lines coincide, we have infinite many solutions. Remember that we're going to you have to remember the class, our previous class, that we was graphing the equations, and we can find, look at that, we can find this type of equation, or we can find this type of equation, this time linear graph, okay, with parallel lines, with no intersection and no solutions, and we can graph a line that one line and the other one coincides infinitely with many solutions. Okay, look at that. Now, solving a system of linear equation by substitution. Okay, we're going to do with substitution. Okay, please everybody pay attention how I'm going to use the substitution method to do this equation. Okay, you don't understand the graph, Vale, don't worry. Okay, don't worry, I'm going to explain again the graph. Okay, very good. Now I'm going to put one equation in y terms. The first equation, oh, with this one is more easy, no? Okay, the first equation is, in this case, 2x minus y, it's equal 1. Remember that this equation in y terms was y, it's equal, yes, 2x minus 1. Remember that we have this equation. I can use this equation on the second equation in this one. Look at that, in this one. Why? Because y is equal to x minus 1. So I'm going to take minus x plus 2, this is a 2. I know that it's ugly 2. 2y it's equal 7. But remember that y is 2x minus 1. Okay? Very good. Oh, let's say it's 5 and 3. Oh, very good. Excellent. I'm going to replace it, okay? Minus x plus 2, open parentheses, 2x minus 1. Very good. It's equal 7. Excellent. Now, minus x plus 2 times 2x, remember 2 times x, 4x, 2 times minus 1 minus 2, remember the signs, okay, it's important, equals 7. Now, we have like terms, minus x and 4x, and look at that, I can move minus 2 on the other side of the equality. So, minus x, remember change the sign, minus x plus 4x, 3x. Okay, very good. It's equal 7, yes, plus 2. Excellent, very good. Very, 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 very good. Now, 3x it's equal 9. Now I'm going to move this 3 over the 9. X it's equal 9 over 3. So x it's equal 3. Look at that, we have the first point, that is 3. Okay, very, very good. Now I'm going to read some comments that you have. Okay, the graph represents the quantity that you need and the people requires. Yes, very good. With the result of graph, very, very good. I could say it's 5 and 3, very good. Yes, very good. X is equal 3. Look at that, we have the answer now. Very good. Now you have to do a value to the variable. Okay, let's say with the graph we can use the equation answer. Yes, very good. Because if you graph it, you're going to find the intercept with the axis. Okay, and the intercept with the two equations. Okay, very good. With the equation, yes, just you can graph. You can do the equation using the graph too. Okay, very good. Okay, I'm doing very good. It's a little more difficult. No, it's long, but no difficult. Okay. Somebody says, I don't know. I don't understand what happened. Okay, don't worry. Okay, let's continue. Let's continue. Now I'm going to remember that x is 3. I'm going to put a line here. Why? Remember, x is equal 3. So I can replace this 3 into this equation or this equation. First of one, I'm going to put it in the first one. In the second one, minus x. This is x, okay? Minus x plus 2y, it's equal 7, okay? But remember, x is 3. So it's minus 3 plus 2y, it's equal 7. Now, I can move this 3 to the right side, okay, and change the sign. 2y, it's equal 7 plus 3. 2y, it's equal 10. Now, I'm going to pass these two to divide. Y, it's equal 10 over 2, and simplify the expression. 10 over 2, y it's equal 5. Excellent, people. Look at that. We have the answer now. Yes, you can do it. Let's say, and we can use what the other right, or the last form. Yes, you can do it. Yes, don't worry. Look at that. We have x equal 3 and y equal 5. And yes, it's true. Look at that. X is 3 and y is 5. Very, very good. That is the substitution method. You can do the substitution method, okay? You can do it in this form, if you want, in this form, or you can use the graph method. The graph method is put all the equation in y terms in this case, okay, and graph using the intercept with the axis and the slope, okay, and you can graph 2, 2, 2, and later you can graph the second equation like that, 2, 2, 2, very beautiful line, okay, and find the point, the intercept point, and later you can count the squares and say, okay, in this case, 1, 2, 3, 4, and 5 in y, and 1, 2, 3, and 4, and 3 and x. Very good. Excellent. Very, very, very good. Now, please, everybody, remember that you can check again this video when you need it, okay? And go to the channel in YouTube, and this video will be uploaded in 20 minutes. In 20 minutes, you're going to again with this beautiful, beautiful video, and you can check again the process, the structure process, the graph process, the liner process, and again if you want to watch it again, okay? Very, very good. Now, please, exercise. Very, very beautiful. I know that will be a little difficult in this case. Okay? Why? Because we're going to play. We're going to play with Quizlet. Okay? But in this case, you have a big responsibility. Why? Because you are part of a team, but you are not speaking with your other partners. Oh, okay. So, what do you want? Teams or individuals? Okay. And now we're going to play individuals players. Okay, if you want. Okay, very good. We're going to play individuals. So, um, positive slope. Okay. So remember, we're going to go. I need that everybody go to www.quizlet.live and could check the code 14625. Okay? Very good. While we are speaking or doing something, you can follow only one. Well, yeah, you can use Ready? Please, I need that everybody use your real name. Okay? Use the real name. If you use a nickname, I'm going to read your username. Okay? So please, everybody use your real name. Please, everybody, quickly. Very, very good. Yes, I think you need this person also. Now you are. Now you can listen me. Okay, people. I uh, I delete the music now, so you can hear me now. Sorry, sorry. I was saying that you use quadratic equations. Thank you. That's for Santi that was saying that. Thank you so much. Okay. Vale, excellent that you are here. Please, everybody, I need that everybody use your real name. Use the real name. Okay. If any put another game or another name, I have to erase it. Okay, I have to ban it. So everybody, use your real name, no nickname, no our nicknames. Okay, we are 16 in this moment, so I'm going to wait for 7 more. We are 21, 22 in this moment. So everybody, come on. I need that everybody. Who's Nyanya? No, sorry. Sorry, but I have to raise it because I need real names. Okay? So please use real names. Okay, people? My voice hears so good in this moment. So let's continue with our activity. We have only 9 minutes more, so come on, quickly. Okay, very good. We're 18 this moment. I only going to wait only 1 minute more. Okay, only 1 minute more and begin with our activity. Remember, this class is finished at 20 to 10. Okay. Okay, 18. Okay, 1 minute. Sorry, 18. I'm going to say play. No more. Okay, and let's go. Okay, very good. Grinders, oh, very good. Zebras, very good. Puffins, bison, oh, pickle, oh, that skin is so interesting. Oh, come on. Excellent. I have only 12 questions. Come on, you can do it, bison. Who's bison? Okay, very good. Excellent. Oh, sorry for bison 4. Oh, sorry for pickaxe. Bye bye. Shark, come on, sharks. Come on, ostrich. Sierras, let's go. You can do it. Sorry, sharks. Unicorns, come on. Bison again. Very good. Come on. Oh, so good. Unicorn. Come on, you can do it. Pickaxe again. Oh. Oh, sorry, bison. Bye bye. Pickaxe again. Come on, you can do it. Owls. Owls. Come on. Unicorn 7. Come on, you can do it. Excellent. That's it's so fun. Come on. We have only 5 million more. Come on. You can do it, unicorn. Come on, Pumas. Come on. Zebras, koalas. Oh, sorry, koalas. Bye bye. We got peacocks and unicorns. Look at that. Okay, that's it. So interesting. Oh, sorry, unicorns. Bye bye. You was on here. Peacocks. Very good. Very good. Very good. Very good. Two more. One more. One more peacocks. One more. One more. One more. One more. Come on, peacocks. One more. Very good. Crystal, you're the winner of this game. Excellent. Very, very, very good, Crystal. Excellent. Okay. Perpendicular slopes. Okay. Remember that you have reciprocal or positive reciprocal slope. Remember our table. Okay. Very good. Which quadrant? It's 2 and minus 3. Okay, and the quadrant, okay, remember the quadrant that we're using in this case for x positive but y negative. Excellent. Please, everybody, remember the quadrant. Okay, excellent. Slope, statement of a line, not undefined slope or zero slope. Remember that is how you have to move on the Cartesian plane. Okay, parallel slope. Remember, same slope. Okay, and quadrant. Excellent, very very good. Excellent for the exercise today. So we have to close our class. Remember, we are speaking about linear equations using two variables. Look at that. When we are speaking about economic terms, we are replacing, look at that, quantities for y. Okay? I'm going to show you at the graph with y. Okay? And price with axis x, the x-axis. Okay? That this equilibrium of price of quantities as the solution in our linear system. Okay? That we can find this process using a graph form, okay? Graphing these equations in over the Cartesian plane, or we can solve it using the substitution method. Remember the substitution method that we have put it all in y terms and replace it into the first or second equation and later replace it again into of both equation on only one. Okay? Remember too, one intersection, you have only one solution. Okay? That we can find parallel lines with no intersection and with no solutions. And when the line coincides, it's infinitely many solutions coincide. Okay? When the lines coincide, we can find infinitely many solutions. So remember, our class is over for today. Thank you. Thank you so much for today. Remember, please, if you want to see the video again, please, you can put it again in YouTube. Okay? Please give me a like, subscribe to my channel, and remember, you are in my heart, in my mind, in my soul, and I really, really miss you. Okay? Bye bye. I love you so, so much, every one of you.